while we're doing this, while we're just reading through this small section in your notes, we're also going to be showing you how to insert these in your calculator. It's pretty straightforward, but we're going to use the equations from example 7 that you originally start off with, x equals t squared plus 2 and y equals 4t minus 1.
Why don't you just go ahead and write those down just real quick?
Okay, yeah, that's a good idea. This right here is what we're plugging in as we speak. And so big thing is to put your calculator in PAR mode and SIMUL mode if you're on an 83 or an 84 or 82. On the Inspire,
it just shows up. It's like magic.
Well, you have to go, instead of inserting a function, you insert a parametric equation.
And on Desmos, you just type what you want.
You just type what you want, okay. The calculator will graph, if you do this on the 83 and the 84, it'll graph the equations at the same time, so that if we have an x1, y1, and then an x2, y2, it'll graph those all at the same time, so you can see like their pathways to see if they'll,
if they cross or not.
If they cross at the same time, because that's a big deal. That's why parametrics are so important, is because it's not necessarily an issue if two things cross paths. It's an issue if they're there at the same time, because two things can't really occupy
like the other day
space.
When I was driving in my car. Maybe
we shouldn't talk about that. Yeah. A couple of nice tips. These again are for the 83 and 84s. That if you press clear draw when a graph is up, which is under the draw menu, it will redraw the graph. And so since we're looking at pathways that can be helpful. And then if you're in the middle of something graphing, if you press enter, it will pause it. Press enter again and it'll restart.
Pretty amazing.
If you press on any time on your calculator, it will just stop what it's doing. So if you press the graph button, you realize, oh, I put something in wrong, you can press the on button to stop it.
I picked a t-step with the smallest digits possible. This graph's taking forever.
Right, so you press the on button and move on from that.
Yeah.
You can, with the trace button, like trace the pathway, and it'll go by like t value. So if you're on one set of graphs and you're at like t equals 3, and you press up and go to the other set of graphs, it will show you where that graph is at t equals 3. So that helps you tell if they're gonna be there at the same time or not.
Right.
And so on your window settings for the 83 and the 84, it's in the, it's just on the equation on the Inspire, like it's part of the X1,
it's part
Y1.
of the,
You have the T-min, T-max, and T-step. So that's what values are we going to plug in for T, and that really matters. In general, a lot of these graphs will want something like -5 to 5 if they're just equations. But if it's real life, it's a lot more likely that you'd want like 0 to 10 or something.
For example, you don't count a rocket launch basically until it launches. Until it launches, which is at time 0.
And so
sometimes they don't launch well.
Sometimes they do, sometimes they don't. And so the T-step part of that is if you put in like from 0 to 5 with a T-step of 1, it's going to plug in 0, it's going to plug in 1, 2, 3, 4, 5, and those are the only values it's going to plug in. And so you can get a graph that would like look really like
jerky.
Yeah, jerky.
Not very smooth.
Not smooth. But if you lower that T-step to a smaller number,
like 0.01,
then it's going to be a lot more accurate as you go. And so it's kind of tough to find a balance between, I want the smallest T-step possible without having to wait forever.
But I don't have all darn day to graph this sucker.
Right. So you may have to mess with that some. And that's where that on button trick really helps, because if you start graphing, you're like, that's going to take forever, then you can just change it a little bit. So 0.01 to me seems like a pretty good one most of the time, unless you just have a ton of t values.
Unless you're going like to infinity or something. Infinity. Infinity.
Infinitesimus.